Okay, can you hear me? So I would like to introduce myself. My name is Schon and I work at Deutsche Börse Group. Do you know that company? This is the company which operates Frankfurt Stock Exchange, Eurex Exchange, which is one of the biggest exchange organization in the world for derivatives, options, futures, and these financial instruments. And also it operates International Securities Exchange in New York. And I work there as Python developer of performance monitoring tool of electronic trading system. This is the system which where you can buy or sell your shares, futures, options, and whatever you own or whatever you would like to buy. The system which I am working on, I will show you screenshots. This is the performance GUI of this electronic trading system. It collects data from other components, say daemons, which are running in this trading system. And it collects and measures all performance metrics like latencies, delays, round-trip times between these components. These components send messages between them, and this system collects them and displays them in this fancy web page. There are graphs which are moving during time. When the real-time mode is on, you can select some observables, display them, and the graph is moving, and AJAX calls are fetching new data from the server. You can display histograms. It's on this graph. You can display dotted graphs. Yeah, it's very good job. And the second screenshot is from the dashboard, which shows all processes in the system. It's done using jQuery SVG. All these rectangles responds to clicks, events, and displays these tooltips where you can see other graphs. And this is my job. It's done in Python on web server and in JavaScript using SVG and jQuery float in browser. So we will talk about WSGI frameworks, how they works. They mostly works in similar way, and in next part we will target on synchronization between processes, and we will show some useful techniques when running background tasks. And the last part we will show some interesting features or interesting tricks with get and post data. So WSGI frameworks are mostly similar. They create requests from environment provided by web server. This environment contains data like server name, request method, get, post, delete, put, and also it contains path, port number, and many useful options. The next step in the web server is dispatching URL to appropriate controller function. This controller function returns HTTP response. In Django, it's called next step is controller function. In Django, it's called view function, and the result from this function is returned back to web server. This request object. It's mostly in Django. It's object passed to all functions. But I saw some other techniques when there was a thread local object. It was singleton or Borg object. So you basically import it from the framework and it worked. It depends on use framework. During the time, authentication is usually handled and session is created or fetched from cache or where you store sessions. URL dispatching. In Django, you probably know these regular expressions, but you can also use wildcards in your favorite framework or decorators, where this decorator you can apply directly on this controller function. And at this step, you can also handle redirects and rewrites, similarly as smooth rewrite. WSGI specification also knows the feature called internal redirect. This redirect response contains header location, and if the location contains only path and not the full query string with HTTP / server name, so then it does internal redirect, and no response is returned to client. So you can be surprised if you don't fill full URL there and only path, then you may be very surprised. Sorry. Controller function, it generates HTML content or JSON content or whatever you want to return to the client. It usually handles templates, ORM, data, cache, cookies, and return response, which has got status, headers, content. And it's usually wrapped with error handler. You know this fancy debug page from Django, and this page is in most frameworks. State in web applications. As far you know, HTTP protocol is stateless. It means that all requests are independent from previous requests and from next request. But applications are usually stateful. There is browser state, which is handled by JavaScript, cookies, get parameters, what is in your forms. There is also server state, which consists of process state and session state. This process state are usually DB connections, other connections to cache, open files, local cache, what you cache inside your WSGI process. And there is also shared state, session state, which needs to be synchronized between instances. Shared state. The session is fetched from cache, then usually apply some modify session, and then you return the cache. Then you return the session to the cache, and there is problem because race condition occurred, so you need to synchronize this between processes or all web server nodes. How to synchronize this session or this shared state between processes? You can use SQL databases or NoSQL databases, log files, messaging, e.g. AMQP. You probably know AMQP from Celery, Django Celery. This is asynchronous framework in Python, which uses AMQP internally, but it's a general protocol for sending messages between components. Other ways are XML RPC, JSON RPC, so these are remote procedure calls. Or you can use distributed log manager, DLM. I haven't found any useful DLM manager for Python, so I wrote my own, and I will show you how it works. It provides something called mutex over network. This is how is this DLM used from client side. The client from this context is the WSGI process, and the server is the DLM daemon. So you connect to this client on some host port, and you pass some client name. Every client should have unique name. So you create a lock in every WSGI process you have with this client mklog function, and you pass a log name which is unique. You can create as many logs as you want, and then you can use it same way as you use threading logs from threading module. So you call log acquire, here is the critical section, and at the end you release the log, or you can use it as a context manager using with statement. So now I will show how it works. So in this terminal I will start DLM. So it's listening on localhost, but it's easily to modify to listen on Unix domain sockets or other ways. It's up to you. And in this terminal I will start a client. Now I will create client 1, for example. I will create a lock, call it test. Here I will start another EuroPython process. Import from the element, import log client, mklog. So oh, sorry, this should be client 2. And I will create same log with same name. So these two clients share same log. And in the first process I will acquire a log. Oh, why it's not typing? Acquire. So this first process holds a log, and this second process will try to hold same log. And it's waiting because it's held by the first process. The communication protocol between client and server is text-based. It's very lightweight. And if I release the log in the first client, release. So this process continues running and it holds a log. And if I want to acquire this log again, it's waiting. Surprising. Release. And also release. It has got some disadvantages because if the application fails between this when the lock is acquired, then all other WSGI processes are waiting. So you must be very careful what are you doing inside the critical section, and you have to be careful. I published this DLM on codeactivestate.com, so it's free software, you can use it, it's up to you. So now back to console, back to presentation. So it's easy to use, it can be used as normal log, it works with TCP/IP Unix sockets. And there are disadvantages, as I said, and it's a single point of failure. Another thing, you can run background processes with Apache mod vosg. There is option called vosg import script for Apache, which you can use for running background processes along with normal vosg processes. This process, when it is running, it does not accept requests. Of course, you can run this daemon separately, but Apache then cares of startup, adapt, and restart if the process hangs. These background processes can be used to fill cache, to cache some big data, or to do some expensive tasks. So this is how it works. There is a normal configuration for vosg daemon process. It starts 10 processes with one thread. There is another daemon process called worker, which starts one process, one thread, with display name I am background worker. And this is the invocation of the script. This is normal, this is, you probably know this. This is the content of this daemon. There is function serve forever, which does the expensive task in this while through cycle. Get some data is probably something which takes a long time to complete. So this function cannot be called directly from vosg. So you have to do it at the background. Or there can be some waiting for messages from AMQP, from Celery, or for some asynchronous request. This is there because when this process is started, not from terminal, but from vosg, then the name is underscore mod underscore vosg underscore and then some unique identifier. So this can be started also from terminal and also from Apache. Fun with get and post data. There is a query string which repeats this parameter hello, world, hello, EuroPython. There is param1, param2. And this can be directly translated to dictionary. You know this from Django, request.get. This hello parameter is a list because it's repeated 2 times. We use this equivalency between query strings and Python dictionaries in my project quite often. But what we also use is including multiple query strings into one string. This is JavaScript code. If you have got multiple same forms on a single page, you can iterate over these forms, serialize this form, and if you escape this data, then you will encode multiple forms in a single query string. And this is Python equivalent of this JavaScript. This escape function has got equivalent in urllib.code, and as a result, you will get this very, very long query string. And you can repeat this multiple times, so you can include recursively many forms, and as a result you will receive quite complicated structure, and we use it. I will show you where. Control F. These graphs, there are hidden forms. Each of these series, the series is one line, one color. This is a series. These series are defined by internal forms, hidden forms, and everything is encoded in these recursive query strings. So if you add another series to this graph, it will create another hidden graph, another hidden form, and when the real-time request using AJAX is sent to the server, everything is encoded in very, very long URL. By the way, do you know how are these graphs created? It's using jQuery float library. It's a very interesting library. You can export everything to PNG directly, and you can apply custom functions like logarithmic function to any of these axes. So in case of this histogram here, these values can be very, very small, and at the end they can be very, very big. So when you apply logarithmic function, it will make the graph fitting and nice looking. Yeah. So this very long URL from the previous slide can be directly translated to this Python structure or JSON structure, where all these parameters are recursively inside from the previous one. Okay. Again to this dashboard. This dashboard can be also exported to plain SVG document. There is button to export, so you can send this as a picture. And this dashboard also is real-time updated every several seconds, so you will get overview of the system very fast. Are there any questions to this? No? Okay. I will show you another useful technique. Clears Faxu. Is it running? No. CD. In other presentations, they were saying that Apache is not good for running high available web applications which needs to respond as fast as possible. I think it's not true, because my experience is when the application is slow, the problem is not in the web server, its problem is in the application itself. Science enable. Yeah. So this is running some example WSGI application. What I did, I renamed the process Apache2 to process I am Apache2. There are WSGI processes, and there is also running this WSGI background process I am look server. Do you know how to rename process? It's using this exec function inside bash. Basically, I did it this way. User bin Apache sbin Apache Apache2. This is I copied, or sorry, I moved this Apache2 binary to Apache2 minus bin, and using this exec function, I rename it to Apache2. These spaces are there because if they aren't there, if I delete these spaces, restart. It somehow didn't restart it. Then the name of these WSGI processes is cut to the length of original Apache, because it does some internal tricks with sys arguments or what, something like that. Okay. So this is the end from my side. Have you got questions? You can connect me to LinkedIn. You can find some of my snippets on site Django snippets. And I would like to also say thank you to Deutsche Börse Group, which sends me there and allowed me to present our stuff.
Any question? Yeah.
Just when you were demonstrating your distributed lock server earlier on, what happens if my client that has quite a lock dies? Is there any sort of timeout I can set or anything of that sort on the locks?
In the code, I will show you the code of this lock server. dlm.py. So it uses logging, always select, threading. There is a log object. This is the client side. This is returned to the client when it creates a log. And when the client dies and log is held, probably this is the problem, that all other WSGI processes are waiting. There is a reset function which basically deletes all logs which are held, and everything can continue. So you have to be prepared for this situation, but this situation is not special to my DLM, but this is general. When you have good locking and something goes wrong, then you usually have to restart everything. This is a log server. It uses threading. When the client connects to the server, it creates a new thread, and this new thread, when it receives operation or when it receives a message from the client, this message is dispatched to one of these functions. mklog, mkrlog, acquire, release, and reset. Normal log is like a mutex, mutual exclusion. Rlog is more similar to a semaphore. As many times as you acquire rlog, so then you have to release it same times. I will show you. New tab. Python. Make log, import, create client, mkrlog. Rlog. Something goes wrong. It's probably held. Test 2. Because it is running with Apache, so there is something wrong with that. Okay, DLM. Okay, I will continue with the source. It is running in the for cycle while true. So when the log does not exist, it creates a new log. It's there. If you call the function mkrlog, it will create this error. I don't know what is it, restricted or repeated log. Okay, other question?
Yeah. In the bit where you were putting multiple forms into a query string, a lot of the time with some browsers you'll have a problem if the query string becomes too long. Why not just, if you're using Ajax anyway, why not just post it in the post data as JSON or something like that?
Yeah, it's also possible. We currently use get, but yeah.
Is there a performance?
Yeah, there is a limitation for get parameters length, but we never hit this limitation.
We've not been as lucky.
Sorry?
We've not been as lucky.
Any more questions? Yeah.
So, sorry. What is the typical latency of this application after you've done all these optimizations and improvements?
Could you repeat the question?
What is the typical latency of this application after you've improved it in all these ways?
For our application, we don't use any common framework like Django or Flask, because this application started as a CGI. It was printing all HTML to standard output. And then I joined the project and I said, no, CGI is not a good way how to do it. So I started rewriting to using WSGI. And there was no time to implement some existing framework, so we created our own. And it's very lightweight. It does not have to block any other backend daemons or databases, and it needs to respond as fast as possible.
How fast is that?
Yeah, how fast is that? For these graphs, it usually responds in, I don't know, 50 milliseconds for new data. This is fine. 50 milliseconds is fine. Times around 200 milliseconds, it's worse, and times more, it's bad.
Any more questions? Yeah.
Just one quick question. You mentioned that sometimes you had problems if you acquire a lock and you have a problem. So maybe adding a timeout here in the acquire could solve this, so you can check the problem and not deadlock everything?
I think using timeout is not possible because at server side it uses standard threading locks, and this lock cannot be easily killed, I think so. You maybe can delete this object from other thread. So yeah, maybe there could be a way how to do it. There could be another thread checking if something doesn't go wrong, and eventually killing these locks.
Should you maybe deprecate the lock acquire and lock release and recommend everyone uses the with statement?
If I recommend it, or
Yeah.
why not?
The with statement.
Oh, okay.
So that if you get an exception or anything like that, it will be guaranteed to release.
That's a good idea.
You know.
You mean there is a bug in this?
No, and for client side code, and the client when using it, always use it as a context manager.
Yeah, always use it.
Don't use the acquire and release manually. Always use it within a with statement.
Yeah, this is good advice.
But why did you write your own locking server thing instead of just using Memcache or Redis, some other storage?
Why I did it?
Yeah.
Basically, I saw some locking using Memcache.
Huh?
It was doing sleep inside. It put some key into cache, then it slept, and I think this is not a good idea.
It doesn't depend on Memcache, just some guys just like it.
But Memcache is for other purpose, not for locking.
Yeah. Okay. Any question?
Can you tell us a bit more about your lovely dashboard made with jQuery SVG? Because that looked really fascinating.
Okay. So this dashboard is created using background task. It iterates over all processes in the system and checks their status. Where it is. And when this page refresh, it downloads JSON string from the server, and JavaScript understands the JSON and creates a box. There are already parameters like width, height, top, left for each of these boxes, for each of these elements, and all these data are in JSON. And these graphs are loaded after you click on this box using another Ajax call. This is working basically, it's not some kind of library for these graphs. You basically draw a polyline using SVG, where every pixel is the point of the graph.
Okay, last question here.
Right, this is a short question. Why didn't you use Twisted or Tornado instead of writing this whole mess of socket connecting and everything?
Because Twisted, I don't know much Twisted, so maybe it will be my next task to rewrite it to Twisted. But as far as I know, Twisted is asynchronous, but you need some kind of synchronous locking, not asynchronous. How you keep the client waiting for this? Sorry?
The only asynchronous part is the connection and I/O. I mean, you can still wait for something.
Yeah, but
You have the first level.
yeah, this DLM was for 200 lines, and I think with Twisted it could be much more, or not?
Yeah.
Yeah. Okay.
Okay. So thanks everyone, and thanks for the speaker. Many thanks. As a reminder, if you want to access the video, you can access the files.ep internal address, like EP, like EuroPython. And if you want to have a chance to have a new phone, there is a coding competition sponsored by Google, and there is a Samsung Galaxy. So just be aware of that. Thanks.